Hi guys, Mrs. Homan here with another science video. Today we are starting a three-part series on the Earth-Sun-Moon system. In our first video, we will be discussing days, years, and seasons. In the next video, we will be discussing the lunar cycle, and the last will focus on eclipses and tides. So let's get started. Earth's days, years, and seasons are related to the way Earth moves in space. So, what determines the length of a day? The time it takes a planet to complete one full rotation, or how long it takes to spin on its axis. It takes Earth 23 hours and 56 minutes to make one full rotation on its axis. Comparatively, a day on Jupiter is only about 9 hours and 55 minutes, which means it is spinning much faster than Earth, whereas a day on Venus is equal to 243 Earth days, which means it's spinning extremely slowly. Additionally, we need to know that all the planets, including Earth, spin counterclockwise on their axis except one. Venus is the only planet that spins clockwise. Scientists have several hypotheses about why this is, but nothing definitive. Next, what determines the length of a year? As the Earth rotates on its axis, it also revolves around the sun. A revolution is the motion of a body around another body in space. So a year is the time it takes for a planet to complete one full revolution. In our case, that is one revolution around the sun. Earth completes a full revolution around the sun every 365 and 1/4 days. Of course, that quarter is why we have a leap year every 4 years. Remember, the farther away from the sun a planet is, the longer it takes to complete one full revolution. Mercury has the shortest year, about 88 Earth days, and Pluto has the longest at about 248.5 Earth years.
To illustrate, here I have the Earth and the Sun. The Earth rotates counterclockwise on its axis. It takes about 23 hours and 56 minutes to make one full rotation, which is equal to 1 day. As it rotates on its axis, it also revolves around the sun in an elliptical orbit. It takes about 365 and 1/4 days to make one full revolution around the sun, which is equal to 1 year. Additionally, the most important thing I want you to notice is that the direction of the tilt did not change throughout the orbit. Watch again. The Earth is tilted this way for the duration of its orbit or revolution around the sun.
Before we can move on to seasons, we need to understand one more thing. The planets orbit the sun. An orbit is a regular repeating path that an object takes around another object in space. The planets in our solar system orbit the sun in an elliptical or oval pattern, not a perfect circle as you typically see it drawn. But even though it may be tempting to think that summer is when we are closest to the sun, this is not what causes our seasons. So, what does cause Earth's seasons? Earth is tilted 23.5 degrees on its axis, and the direction of the tilt remains the same throughout Earth's orbit. Notice in each of these pictures how the tilt is pointing in opposite directions, but the direction it points remains the same throughout each picture. There are two things affected by Earth's tilt: temperature and daylight hours. First, temperature. The angle at which the sun's rays strike each part of Earth's surface changes as the Earth moves in its orbit and depending on the latitude. When the northern hemisphere is pointed towards the sun, the northern latitudes get more direct sunlight. More direct sunlight means that heat energy is focused on a smaller area. Indirect sunlight means that the heat energy is spread out over a larger area. Second, daylight hours. Throughout the year, the amount of daylight hours differs. Areas tilted towards the sun travel a longer path through the lit part of Earth and have more hours of daylight. Additionally, this means more time absorbing heat energy from the sun. Uncoincidentally, seasons are characterized by a pattern of temperature and daylight hours. Summer has higher temperatures and longer days. Winter has lower temperatures and shorter days. Additionally, that is why when it is summer in the northern hemisphere, it is winter in the southern hemisphere. Because when the northern hemisphere is pointed towards the sun, the southern hemisphere is pointed away. An equinox is when sunlight shines equally on the northern and southern hemispheres. This would be during spring and fall. A solstice is when sunlight is at a maximum in one hemisphere and a minimum in the other. This is during summer and winter. The summer solstice in the northern hemisphere is on June 20th or 21st and is the longest day of the year, when we experience the longest path through the lit part of Earth. The winter solstice in the northern hemisphere is on December 21st or 22nd and is the shortest day of the year, when we experience the shortest path through the lit part of Earth.
So I've already told you that the Earth's tilt causes the seasons. Now I'm going to show you why and how to tell on a diagram on a worksheet, quiz, or test. To start, you're looking at the Earth from the perspective of the sun. Notice the Earth's tilt is pointed away from the sun. Second, notice from the side view of Earth. Half of the Earth is in daylight and half is in darkness. However, the daylight and darkness is not distributed evenly among the northern and southern hemispheres. The North Pole is experiencing 24 hours of darkness. Additionally, notice near the equator, they're getting direct light. So direct light and heat energy. So that light and heat energy is focused on a smaller area near the equator, resulting in higher temperatures. However, near the poles, that we are getting indirect light and heat energy, resulting in lower temperatures. Since the seasons are characterized by daylight hours and average temperatures, that means we are experiencing winter in the northern hemisphere. So the first step in determining the seasons is to note the direction of the tilt. Now I'm going to be discussing only the northern hemisphere, just to keep things simple. And additionally, you will always know what season it is in the southern hemisphere because it is always the opposite of the northern. The second thing you need to remember is the order of the seasons. The seasons always go in order: winter, spring, summer, fall. So now I'm going to start the Earth's orbit around the sun. Here at my first stop, I am at an equinox. I know that this is the sunlight is falling equally on the northern and southern hemispheres. I know that this is the spring equinox because I was just at winter. Moving on in the Earth's orbit. Now the northern hemisphere is tilted towards the sun. The northern hemisphere is experiencing longer days and more direct light. Therefore, it is summer in the northern hemisphere. Additionally, this is the summer solstice, when the sunlight is at a maximum in the northern hemisphere. Moving on in the Earth's orbit, I am now at another equinox. However, this equinox is different from the previous equinox. That sunlight is shining equally on the northern and southern hemisphere. However, this is the fall equinox because fall comes after summer. And moving on in our orbit, we are now back at winter in the northern hemisphere. It is the winter solstice when the sunlight is at a minimum in the northern hemisphere. So remember, your first step to determining the seasons is to note the direction of the tilt. If the northern hemisphere is tilted towards the sun, it is summer in the northern hemisphere. If it is tilted away from the sun, it is winter in the northern hemisphere. You always know whether it is spring or fall based on the Earth's orbit and the order of the seasons, and you always know the season in the southern hemisphere because it is always the opposite of the northern.
To summarize, the length of a day is determined by how long it takes a planet to complete one full rotation on its axis. On Earth, that's 23 hours and 56 minutes in the counterclockwise direction. The length of a year is determined by how long it takes a planet to complete one full revolution. On Earth, that's 364 and 1/4 days to make one full revolution around the sun. The seasons are caused by Earth's tilt on its axis. Earth is tilted 23.5 degrees on its axis, and the direction of the tilt remains the same throughout Earth's orbit. The tilt causes temperature changes as well as changes in number of daylight hours throughout the year. Thank you so much for watching. Have a marvelous day.